Hello everyone. This lecture covers the first part of our discussion on transportation network problems, and we will focus on today on understanding the hierarchy of cities and measuring the hierarchy with the specific network measures that will introduce three measures. And for details about today's lecture and the items and the method, then we reference in each slide. Please consult our textbooks and the articles that we cite. So you can get a number of information also from the many web pages, because this is a pretty popular method. So let's begin with the structure of today's lecture, and we will talk about why hierarchy is important in transportation network science and how to measure. Again, there are a number of measures that have been developed in the transportation science and the transportation geography, but we will study about only three methods which are well introduced and very popular and very easy to compute. And then the next step is to interpret. How to interpret the result in terms of a network vulnerability when we apply the measures to the transportation system. As a starting point, cities or regions are typically organized according to some certain rules or patterns and the processes. We are not so sure which pattern, which underlying the factors are really affect the kind of pattern. However, that's kind of point that we want to study. So as the glimpse of the hierarchy, as you can see from the satellite pictures on this slide, areas or cities, with the brighter lights usually represent the larger cities, and while the dark areas are no light area, indicating less economic activities. So therefore, it is pretty natural to assume that there is some certain hierarchy among cities based on their level of economic activities. And then how to classify cities, regions, airport if their interactions among them are known? Because transportation is what we learned that it is what driven, the demand between between cities. So it's generally creating the different level of interactions. So the next step is then what tier in the hierarchy is your hometown's airport, or what kind of some different level of services are provided by the cities when they are classified in some certain hierarchies. This sort of the questions are pretty natural, and then we try to answer for the questions using some method. As we learned from the previous lectures, there have been many efforts to draw a hierarchy among cities or regions, and then this is the very, very general diagram to show hierarchy. This figure is an example of a hierarchy of cities with airline passenger flows among them are known, and then this sort of classifications are really based on the theory by Walter Christaller. And then this diagram also shows that there are three different levels. The first, the top tier level consists of the big cities, right? The LA, Chicago, and New York. So we call that's the first tier cities, and each with a group of smaller cities. So usually upper level cities have a certain level of influence to the lower tier level. So I mean, for example, LA here, LA has now included some sets of smaller cities, and as a second tier and third tiers, and that means LA has some strong power to influence and have some higher upper the service levels to the second level or third level. And how we define those hierarchies? So in many literature say the first tier cities we call dominant center, and second tier is the subdominant, and then the rest of them we just call the others. We start with a classical method to draw the hierarchy, which is called, the Neustein-Dacey method. So the original of the method were published by the Dacey in 1961, titled the A-graph theory interpretations of nodal regions. So they published in the papers and the proceedings of the regional science associations. And this method is pretty popular and very, very, useful to decompose the hierarchy. The Neustein-Dacey method assumes that there are 3 levels in the hierarchy of cities. The top level is usually comprised of the larger and more prominent cities, referred to as dominant centers. The next level consists of the subdominant centers, which are typically lower tier cities that receive flows from the dominant cities, while also sending a significant flow to smaller centers. Then we define this as others. The third level consists of the others, they kind of small the rest of the cities, which are the remaining cities that have a smaller flows to subdominant cities. Okay, let's figure out how to determine dominant, subdominant, and others using flow metrics. So let's do an exercise with this small example, and then just assume that you have origin and destination flow metrics among among handful of cities. Notice that this matrix is a symmetric, which means that the upper triangle of a value and the lower triangles in the value are pretty identical. We do use this symmetric metrics for easy understanding of the procedure. Okay, then now you have this audio metrics. And the first step is to find the largest flow of each city in a row and mark them. The table now ranks the cities by the total amount of flow. So for example, and you can see the right column. I just sum up that the total amount of flow. The New York is the #1, the city in terms of total flows. The second is the Chicago, LA, San Francisco, Buffalo, and so forth. And then you just mark up the largest flow in terms of each row. For example, in terms of the first row, the New York has the largest flow to Boston. So I just just underline that the Boston is the largest flow of the city to the New York. And what about the Chicago? Chicago has the largest flow to New York. So I just say mark down. In terms of LA, LA has the largest flow to SFO, that's San Francisco. Like that, you just mark the red mark that to the other rest of the cities to the SLC, that's the Salt Lake cities. That's the first step. And then the next step is to identify the city that receives the largest flow in terms of each city that we had, but just double check that. And then you need to have only one the mark of cities. Okay. And then the next step is to determine the hierarchy, which is a little bit tricky, but it's kind of something the procedure that you need to do very carefully done. First of all, just the example. First of all, take a look at the New York. You know that the New York has the largest flow to Boston, right? And then I think about that. New York is greater than Boston in terms of total flow, which means that New York becomes dominant city to Boston. Follow me, right? Okay, you now set up that the hierarchy between two cities, New York and Boston. And then take a look at the figures on the right, kind of a figure showing that the hierarchy. So you see that the New York on top and the Boston is a subdominant to the New York. Okay, let's figure out the other cities. Let's move over to Chicago. Chicago has the largest flow to New York. And then now, New York, we know that the New York is greater than Chicago in terms of total flow. So New York is a dominant city to Chicago. So like that, now Chicago becomes subdominant to the New York. So you just draw that hierarchy in the right figures. What about LA? LA has the largest flow to the San Francisco. So LA is greater than San Francisco. So LA becomes dominant to San Francisco. But there's no big relationship or dominant or subdominant relationship between New York and LA, which means that, hey, we have now two separate hierarchies in terms of New York and in terms of LA. Now let's move on to Buffalo. Buffalo, the largest flows to New York. Okay, so we now realize that the Buffalo is a subdominant to the New York. So I just put the New York on the first figure. Now we found that the New York has four subdominant cities: Chicago, Buffalo, Boston, Detroit. And now take a look at the Kansas City, that is KC, in the middle of all the metrics. Kansas City has the largest flows to Chicago. But now we know that the Chicago is a subdominant to the New York. But the Kansas City has the largest flows to Chicago. So now we realize that Kansas City is what? Subdominant to Chicago. Like that, you can easily find that the Indiana, that's also subdominant city to the Chicago. Like the Denver on the bottom, is that the Denver has the largest flow to San Francisco. So you know that the Denver is a smaller city than San Francisco. So between two cities, San Francisco and Denver, we now realize that Denver is subdominant city to this San Francisco. By doing this kind of procedure from the top city to the bottom one, that's SLC, you can create this hierarchy. This is what the core the essence procedure of Nuisance essay the method. So what is the useful aspect of this the procedure is that if you have the OD matrix across a different era, like a 1940, 60, 89, and by doing this Nuisance the procedures, you can create the hierarchy using the metrics or the metrics of the time each. And then now you see that there has been some change of hierarchy between 1940 to 60, 60 to the 89. But for example, here, New York is always top city, top tier. So which means that New York has kept in there the dominances, the occurs more than 40 years. This is one example how to interpret the hierarchy using Nuisance method.